All right, hi, and welcome everybody. So in this video, we are going to walk through how we can interact with an R Markdown document in RStudio. So I'm going to assume at this point that you've already gone through the instructions and installed R and installed RStudio, and those are both working for you. So the first thing I want to do is open up the document that's going to go along with this video. And that document you can find on Canvas. So you want to go on Canvas and download the reading document for this first video. I've done that already. So I'm going to go in, once I've opened up RStudio, into the file menu. I'm going to open up the file, which I have stored in 3382 R code, getting started, EDA in pre-class. So this file is called Reading 01 Intro to R. Open that up. And so now that file has opened on my window, my RStudio window, and I will zoom in on that just to make the text a little bit bigger. So the first thing to note with RStudio is there are 4 different what we call panes on this screen. So down below, where you can see text appearing, is what's called the console window. And this is where code is actually executed. We're really not going to be entering code from the console. We're mostly going to be entering code in our code cells in an R Markdown file. So we don't need to worry about the console all that much. The script window, that's the main window over here where we are viewing R Markdown. So typically when we're working in RStudio, we're going to be working in the script window editing an R Markdown file. And so how do I know that this is an R Markdown file? The file extension is .rmd on this file. The workspace window is the window that's up in the upper right-hand corner where you can see the global environment button. So this will keep track of any objects that you've opened up or assigned during your session. And then in the lower right corner is the help window. And this is where you can view help documentation and see some of the plots and look at what packages might be installed during this session. And you can rearrange your panes and resize them to fit your needs. Since we're mostly working in the script window up top, I'm going to leave that as my main window. And I don't really need to see the other side windows very much right now. And so while you're working in R Markdown, there are 2 modes that you can use. One is called the source mode. One is called the visual mode, and those you can see up top. And as I hover on them, you can also see I'm using a Mac computer, what the keyboard shortcuts are to toggle between these 2 modes. So the visual mode is when you see the so-called Markdown rendered nicely on your screen. If we go into the source mode, you're just going to see the raw Markdown code. So here is the stuff that's actually typed, and you can see that there are some double asterisks to make things bold. So here we're kind of telling R how to typeset the text that we're entering, and when we go over into visual mode, that does the typesetting for us. So I like to work in source mode because I like to have a little more control over how things are going to be displayed. When I'm presenting things, I would definitely want to be in visual mode since that's a lot easier to read for other people. Whichever mode you're in, just realize that these are dynamic documents and that you can add things here. So I can type text down here and it's going to appear in visual mode. And if I were working in source mode, you can see that same exact text appeared over here. But over here, I can type double $, bold text. And it looks like this. And when I click on the visual mode, that should appear as bold text. So we'll be working in both modes for the purposes of this video. I'm just going to stay in visual mode because it is easier for you to read. So we're going to go through a couple of questions down below to enter our first couple of R code commands. And that's going to require 2 packages to be loaded during this session. One is what's called resample data, and one is what's called dplyr. And so if you have not already done so, then you are going to want to install these packages. And so I'm typing the command on how to do that in the console down below. So you would want to enter install packages and then enter resample data in quotes and enter dplyr in quotes. So you would want to enter exactly what I've highlighted down below into your console and install both of those packages. And once you've installed those packages, if we actually want to use the libraries of functions and data that are in those packages, each time we open an R session, we're going to have to load those packages with the library command. So that's what's going on. So what we're looking at here is actually our first code cell. So you can see that it appears different. And there's a play button over here, meaning I could run these lines of code. So I'm going to hit play to run the current chunk of code. And it doesn't look like anything has happened. But actually what's happened in the background is that these two packages were installed. Let me just type that again. And the reason why we don't see any output on the screen here is because I have this message equals false option entered in this R chunk code. And so we'll get into some of these options with the code chunks. Here's a doc. Here's just a reference for you to go to if you're curious about it. But the rest of the code chunks here, we're not going to have this option. So you'll see the output that comes out of running those codes. But hopefully now you've run the code to get the resample data and dplyr packages loaded up for this session. And just to mention, as I'm looking, over here, you can see the tab for this markdown file that we're working on is red, and that means there are some changes that haven't been saved. And so if I want to save those changes, you can do like the keyboard shortcut of Command S or go into the file menu and just choose to save. Okay, and so one thing that's really nice about R, it's a really powerful coding language for doing statistical analysis and data visualization. And it's really intuitive based code that the commands, the functions have names that really make intuitive sense. So hopefully the learning curve of getting started in R or in RStudio is going to be a little bit less than it might be with some other more complex programming languages. So we're going to be working in the next couple of questions with a data set called FlightDelays that lives inside the package resample data that we just loaded. So up top, you can see there are a number of helpful commands that we might enter into R to get a summary of this data set. So the first thing is, how can we enter a new code chunk in R? And so I can either type 3 of these single quotes that appear, you know, on the upper left-hand corner of your keyboard, probably, followed by an R in curly braces. And if I hit enter, that creates an R code cell. So if you missed that, again, what I did is I typed 3 of these symbols followed by an R in curly braces and then hit return, and that creates an R code cell. The other way that we could do that would be to go up into the insert menu up here and choose to insert a code chunk and choose to do it with R. But we don't need to have 2 chunk codes here. So I've got 1 chunk code or code chunk, and I would like to figure out some information about this FlightDelays data set. So in R, one really nice thing is that we can get help just by typing a question mark and then the thing that we would like to learn about. So for example, I would like to know what is going on with this FlightDelays data set. So I'm going to type question mark FlightDelays, and over on the side in the help window, we can see some summary about this data set. We can see that this data set has 4,029 flights in it from United and American. These are flights that went from LaGuardia out of LaGuardia in May and June of 2009. And we can see oftentimes here, they don't actually show it. They'll list what are all of the variables in this data set. But we don't see that information from this help documentation. So let's add another code chunk. And instead, let's run the following command, summary flight delays. And we're going to run this by hitting the keyboard shortcut, which on Mac is the command and the return key. And this gives me a more detailed summary, numerical summary for all of the variables in this data set. So I can see there's ID, carrier, flight number, destination, etc. So these are really nice, helpful ways to summarize the data. If you would actually want to see what the file looks like, what the data set looks like, we could do head and then flight delays. And that brings up the first 6 rows of the data set. So you can see each row is an observation and each column is a different variable. So here's this data frame, flight delays. And if you want to view the entire data set, then you can do view. And here the DF that you would enter would be the name of the data frame, which would be flight delays in this case. So this question over here was asking us how many variables are in this data set and which are numerical and which are categorical. And so down here, we could see exactly how many variables there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different variables. And we can see that carrier is categorical, delayed 30 minutes is categorical, and all of the rest are numerical, except for month, excuse me. So we can see that month is categorical. Things are being grouped into May or June. Delayed by 30 minutes is categorical. They're split into yes or no groups. Carrier is categorical. It's American or United. And destination is also another categorical variable for each of these airports. ID, flight number, departure time, the day, the flight length, the delay, these are all numeric variables. As far as how many observations are there in total, we haven't gotten that information just yet from either of these summaries, but we can get a sense here that if we added the total number of American and the total number of United, that would tell us how many flights there are, and we can do that over here. There are certainly other ways that you can get the number of observations out more directly, but just to show that we can also do simple arithmetic in R, we can see that there are a total of 4,029, and that matches what we saw from the documentation over here. So I believe this answers the questions that were asked here about how many observations, how many variables there are, and which are numeric and categorical. Ultimately, we might want to answer some statistical questions like which airline is more likely to have a flight that's delayed and so on. But let's ask a simpler question to get things going. Let's just say, I want to know which airline in the data set, United or American, has more flights in the data set. Well, we kind of saw that from the summary up above. Another way that we could calculate this is using what's called the table function in R. So if I want to create a table, which is going to count up out of all of the observations in the data set, how many of them have certain class of output, I'm going to enter table, and then I need to enter my vector of values. And so this data is coming from flight delays. And in particular, the variable that I'm interested in is the carrier variable. So notice here, this $sign that I typed in between the data frame name and the column name is what helps us identify which column of the data set we're going to be working with. So the flight delays data set has all of these different columns, and we're just going to focus on the carrier column over here. And the table function is therefore going to look at what are all of the entries in the carrier column and count up how many times did each of them occur. So there were 2 different airlines that occurred. and American occurred 2,906 times. United occurred 1,123 times. So the table function gives us a nice way of counting up how many occurrences we have for categorical variables. Okay. So oftentimes we're going to want to run several lines of code, and we might not want to see the output of every intermittent stage of those calculations. So sometimes we just want to run a code and we want to store that output someplace because we're going to use that output as input into a future command. And so how we can assign objects in R is typically using this arrow symbol pointing to the left, which we get by using the two characters. So we have this character followed by that character. You can also use an equal sign for assignment. Some of the times I will just say that these two characters are not exactly, don't work the same. So the arrow and the equal sign are the same in many situations, but not always. So it's certainly much more commonly used for assignment to be safe to use the left pointing arrow. So for example, taking that same command that we entered above, if I enter table flight delays carrier, but instead of just entering this command, I'm going to assign the output of this command to this object airline. So let's run this code. And you can see on the window in the upper right, in the environment window, we can see that this airline object was now created. It's an integer. It's a table that consists of integers, and we can see exactly what the entries are in that table. But when I ran it in the code cell over here, nothing came out, because what we did is we had the output stored in another object. And so if we actually want to see the output, we need to print it to the screen. And so in the console here, I've got two different ways that you could do that. So we could just type airline, and whatever is stored in airline is going to be printed to the screen, or we could type print airline, and that does the same exact thing. And so since these two commands do the same exact thing, there's really no need to enter the print command in R unless you really want to. So I'll just say, sometimes it's nice to display the output of each intermittent step, and sometimes, we don't need to see the work of every single step of several lines of code. So you'll kind of get a feel for that as we are going on and progressing in our coding. Okay, so finally, when we're summarizing data, a table is nice, but if we had a really large data set with lots of possibilities, lots of rows and lots of columns, then a table might not be so aesthetically pleasing. And so that's where plots typically come in. And so the type of plot that you use really depends on what type of data you would like to represent. So in this case, we are working with the categorical variable of carrier. And so rather than look at this table, if I wanted to create a visual plot of that output, I could use for categorical data, a bar plot is a very common way of presenting categorical data. And what I input into the bar plot is actually the table that we just calculated. So I can either type table and then type flight delays, $ carrier. But we've already calculated that table, and we've stored it to an object called airline. So I'm going to comment out this code above. So here's a nice little thing that whenever I put a pound symbol on a line of code, everything that appears after that pound symbol is kind of negated. It'll appear on the screen, but it's not going to be run in your code cell. And this second line of code down here is going to be a little bit more efficient than the top one, because the top one is going to do two commands. It's going to do, let's create the table, and then let's create a bar plot from that table. But we could cut down the work that the computer needs to do because we've already calculated that table. So I'm just going to add a bar plot to the airline table. And out comes a bar plot of that table, and we can see how many flights, relatively speaking, were American in the data set compared to how many flights were United. So these are really basic plots just to get us going. In class, we're going to work on other types of variables and how to improve the visual appearance of these plots, how to add some options to make these plots look a little bit nicer. But the point here is just to get you started working in R Markdown and running some basic lines of code to summarize and present some data in a large data set, such as the flight delays data set. And the last thing I want to mention is when you're sharing these documents, when you're handing in a homework assignment, you may want to kind of hand in a nicer typeset report in a PDF format or in an HTML format or as a Word document. So those documents are what we call static because you wouldn't be able to run any of the R code in those documents. But they're more universally shared. So particularly if you're going to share your work with someone who doesn't know how to use R, then you probably would share an HTML file or a PDF file. And so how you can create those static documents is by knitting them. And so up here is this little blue knit button over here, and you can choose what sort of file you want to knit to. So the safest file to knit to, the one that's most universally able to be shared, would be HTML. So I'm just going to knit to HTML. And you can see the console was running some commands. And out pretty quickly, we get this nice static HTML document that has kind of things typeset in a really nice way. So we can see the R code as well as the output that comes out of that R code. So that was me knitting this to a HTML file. I'm going to knit next to a PDF, and you can see down here in the console, there's going to be a bunch of commands that are running. So there's a lot of work that's being done. And now I'm trying to knit this to a PDF file. It's thinking, and here's a PDF file. So the output looks pretty similar in the PDF and in the HTML formats. So that's a lot of information to get you going with R Markdown and working with R Markdown in RStudio. And we'll get a lot more work in on this in class together. Thanks.